Hi. This video is regarding perpendicular bisectors, definitions, and examples and theorems. So basically, it's more informational. So let's get started. Here's your vocabulary that we'll be using. A perpendicular bisector is a segment, ray, line, or plane that is perpendicular to a segment at its midpoint is called a perpendicular bisector. Equidistance means the same distance, so these two would be equal distance. AB is equidistance to P here. Concurrent, which we'll get to at the end, is when three or more lines or rays or segments intersect at the same point, and they are called concurrent lines, rays, or segments. And the point of concurrency is the point of the intersection. And the circumcenter, the point of concurrency of the three perpendicular bisectors of a triangle is called the circumcenter of the triangle. So when you're talking about the triangle, we'll call it a circumcenter. So here's your important theorems. In a plane, if a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if CP is your perpendicular bisector of AB, then CA equals CB. All right, and the converse is also true. If you have a point that's equidistant from the endpoints of a segment, then it is on the perpendicular bisector. So this point is equidistance, P, from the endpoints here, A and B, of a segment. So it is on this perpendicular bisector. If DA equals DB, then D also lies on the perpendicular bisector of AB, because this bisects this line. So we get to some examples. AC is the perpendicular bisector of BD. Find AD. So first of all, we have to find X. So we know that these two sides are equal according to our theorem, perpendicular bisector theorem. So set them equal to each other. I'm going to add 6 and subtract 4x from both sides. So subtract 4x, and you're going to get 3x equals, if you add 6 here, 6, so x is 2. And then to find the length of, what do we need? AD, you plug it back into 4x. So 4 times 2 equals 8. Now, let's see what this says. KN is a perpendicular bisector of JL. So what segment lengths in the diagram are equal? And is M on KN. And this is from our second theorem. So it's M is equidistant from J and L, because these two numbers are the same. And so by the converse of the perpendicular bisector, M is on the perpendicular bisector if you extend that. So let's look back at this. So KN bisects JL. So NJ, where's N? NJ NJ equals NL. And because K is on the perpendicular bisector, then these two sides are the same. And KJ equals KL. And the diagram shows that MJ right here equals ML. Okay, checkpoint. What segments are equal? So we already are given that these two are equal. And these two are equal because JK is a perpendicular bisector of JH. So these two are equal. Also, J is on the perpendicular bisector. So J equals JH, this one. Now it says find GH. So first of all, let's, since these two equal, set them equal to each other. Subtract x from both sides. So you get x equals 1. Now to get the total length, just plug in your 1 here. So this is going to be 2. And you plug in 1 here. This will be 2. So 2 plus 2 is 4. Now let's see. We have another example. Oh, we already did this one. Okay, so we're good with that. And finally, we have our theorem, the concurrency of perpendicular bisectors of a triangle. So basically, your perpendicular bisectors, there's P. So that's your point of perpendicular bisectors. Therefore, if PD and PE and PF are perpendicular bisectors, then PA equals PD equals PC. And that's it. Thank you. Have a nice day. Bye-bye.